Alrighty, so we're going to approach lesson 3-9 today. We're in the 9th lesson of Unit 3, Perpendicular and Angle Bisectors. You'll be able to identify both types. These are two types of bisectors. You have a perpendicular bisector and an angle bisector. And we'll talk about what each of those means and how they relate into triangles. Let's go on. You're going to go ahead and take a few minutes and do this do now. It's very important you focus your attention on this. This is now starting to lead towards more of an exam review type do nows so that we can be ready for exam unit 3, which will be coming up in a little bit over a week. Okay, so remember that in this particular situation you have you're given triangle QRS is congruent to triangle TUV. Okay. So QRS and then TUV, right? QS, they're telling us, is 3n plus 4, and TV is 6n minus 8. Find the length of QS and TV. Now, before we go any further, let's just pay attention to this part right here, okay? Let's pay attention only right here. We're going to have two triangles. Let's draw them. So we got QRS, okay? The first one, however you want to put the order, it doesn't matter, but the second one does. TUV. Right? If I start at Q here, then I'm going to start T here, okay? So T, U, and V. And we're told that QS down here is equal to 3n plus 4. We're also told that TV down here, and this is 6n minus 8. Well, if that's the case, and these two are congruent triangles, that means that these two sides are also congruent. So all we really have to do is just set these two expressions equal to each other. So we'd get, I'm just going to do it in I'll do it in this 3n. I'll just do it up here. 3n plus 4 equals 6n minus 8. So 6n minus 8. I'm going to erase just a bit here. Okay, so at this point then it's just a matter of solving for n. So 3n minus 3n both sides, right? At this time I'm going to add 8 to both sides. This goes away. And now I'm left with, and I'm just going to put the n's on this side over here. So I'm left with 3n. 6n minus 3n is 3n's equals to 4 plus 8. Well, that's 12. We'll go ahead and do our last step here. We divide both sides of the equation by 3. Okay, and now we get n equals 12. Now, this only helps us to solve for what we're being asked to. So we're going to go ahead and take this n here. And it doesn't matter because remember QS and TV, which we're asked to find the length of, well, they're the same distance, so we really don't have to find one of them. So I'll just go ahead and just plug it right here into this n value right here. Okay, so I'm going to go get this n and I'm going to plug it right there. So I'm going to say 3 times 12 plus 4. Okay? I'm terribly sorry. I realize right now I just made a little mistake. Let me go ahead and fix that. It was not 12. 12 divided by 3 is actually 4, right? So instead of 12 here, I'm going to say 4. Okay, 3 times 4 is 12, and 12 plus 4 equals 16. There's my answer. All right. Okay, so just to go back again, today we're learning about perpendicular and angle bisectors. So let's talk about each one of those things here. So specialty lines. These specialty lines are lines like angle bisectors, right? And we're going to talk about what this is here. An angle bisector starts at a vertex. So let's take this line right here that we're given, right? This line right here. And it starts at the vertex here. Okay, so it starts right here at this vertex. And bisects the angle there. So it bisects this angle, right? This angle, let's say this right here in gray. Well, that's really not the one color I wanted. This angle here, it bisects it into two congruent, or two smaller congruent angles. So you have this angle and you have this angle, right? And they are now congruent. So it basically splits the angle in half, in two equal halves. Okay? So additionally, any point on an angle bisector is equidistant from the sides of the angle. So what does that even mean? I'll talk about it a little bit more in a second, but it looks like this. So again, I have an angle here. Okay, I have an angle bisector comes out like this, cuts this angle into two equal halves here and here. Okay? All right? So switch the colors up. Okay? And that means that any point from here is always going to be equidistant to the sides. Okay? There are 3 angle bisectors in any triangle. And let's go ahead and look at what that means. Let's draw 3 different triangles. Well, let's say they're all, in fact, the same triangle, right? I can have an angle bisector come from this vertex and come this way and form 2 congruent angles. I can have a angle bisector come from here on this side and form 2 congruent angles. Or I could have it come from this side, right? And form 2 congruent angles here and here. So 3 different bisectors in any angle. Let's go on. The angle bisector theorem says if a point is on a bisector of an angle, then the point is equidistant from the sides of the angle. Well, what does that mean? Let's take a point. Let's take a few points. I'll take this red point right here. I'm going to take this green point right here. And I'll take this orange point right here. We'll just right where D is. And what this is saying basically is that if we say from here to here, that red point to get from that side to touch this side of the angle AB is the same distance as it would go from here to touch AC, and same thing here, right? And so these guys here are basically equidistant from the sides of the angle. Okay, I'm going to point that out in red a little bit here, so to show you that the distances would be equal all the way through, right? So in this case, then, we have a statement we can make. It says if AD, right, the bisector here, bisects angle BAC, AB is perpendicular to BD. So let me do a little erasure here. Okay, let's go ahead and start it again. So if AD bisects BAC, so if AD bisects right here at BAC, and let's say BAC is this angle here, then AB, here, is perpendicular to BD. And it is, right? There's a perpendicular relationship set up there, which means that it's 90 degrees. Well, the same is true on the other side. AC, right here, is perpendicular to CD, which means they form a right angle. And that's what these little right angles are here, right? We were told those little right angles are right there. Okay? So if that's the case, then, right here, we would say, then, BD, I'm going to write it down here, it's a little bit easier for me to write. BD is congruent to DC. Okay? So that little green part right here, so this statement is saying that this one here and this little one here are congruent. Okay, those little segments that are created by that perpendicular relationship. Remember, perpendicular, if you forget, perpendicular is a 90 degree, this is the sign for symbol for perpendicular, and it forms a 90 degree angle. 90 degree angle formed. Okay? So you always have a bisector theorem, right? We have an angle bisector theorem here. We have its converse right here. The converse is basically working from the finish line to the beginning, as where the angle bisector starts at the beginning and works towards the end. Don't worry so much about that, what I just said, as they're basically the same thing but working in different directions to prove that this is correct. So the converse of the angle bisector theorem states that if a point is on the interior of an angle and equidistant from the sides of the angle, then the point is on the angle bisector. So what does that mean? Let's go ahead and take this point here, D. If a point is on the interior of an angle, the angle here in this case is that, right? BAC. Okay, so this is like the main angle. And they're saying if a point, let's take it here in orange, D, is on the interior, is on the inside of this red angle, right? On the inside of BAC. It is equidistant from the sides. We know that, right? We're told that and that. And you see those little tick marks there? That's telling us that little tick marks here are telling us that these two segments are the same, which means that D is the same distance from D to B, is the same distance from D to C. Okay? And it's told if this is the case, then D is actually on top or lies on the angle bisector. Okay? If that's the case, then if BD, which we said here in orange, right? If BD here and DC are congruent, AB here, AB and BD, so AB and BD are, that's perpendicular again, that little symbol, and AC and CD is also perpendicular, there's a little symbol there, right? Then this is true. The angle BAC is congruent to angle CAD. Okay, so basically, these theorems are just to prove that angle bisectors do what they say they're doing, and that's cutting angles in half. So let's go ahead and go on to these slides here now. So perpendicular bisectors, okay? Now we just have angle bisectors. Remember what we just talked about here were angle bisectors. Angle bisectors. Perpendicular bisectors are kind of the same, but they create 90-degree angles with the side that they intersect. Let me explain what that means. So perpendicular bisector theorem, let's go ahead and take this first part here. If a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. So again, let's go ahead and, you've been using point D, so we'll go, if a point, right, lies on the perpendicular bisector, and I know it's perpendicular because it created that little 90 degree right there. Okay, it created that little 90 degree right there, it's 90 degrees, right, perpendicular. Then it is equidistant from the endpoint of the segment. It says from B to D is the same distance as A to D, right? These things are equidistant or equal segments. And if this holds true, then this is what happens. And we have this is what happens. AC, let me do it in a different color here. AC is congruent to BC. Okay, so that means this side and this side would also be congruent. Okay, let's take the next one here. The converse of the perpendicular bisector theorem. This says if a point is equidistant from the endpoints of a line segment, which means it's equidistant from the endpoints of a line segment, then it is on the perpendicular bisector of the segment. So if this point C, for example, this will be the point we talk about, if it is equidistant from the endpoints of a segment, so from here to here and here to here are equal, then it is on the perpendicular bisector, right? So that means it's actually on the bisector, which in this case would be CD, right? This is CD, this is our bisector. Okay, let's take this here. So again, if AC is congruent to CB, we've established that, and CD, which is this orange line here, right? CD is perpendicular to AB, then D, this point here we already talked about here, D lies on CD, which is the perpendicular bisector. Okay? It may sound kind of obvious, and it is, right? It's just a mathematical way of proving that, again, these perpendicular bisectors are creating 90 degrees with the lines that they're crossing. So let's go ahead and move right into the my turn, your turns, and then we'll go independent practice and an exit ticket. So find X and the measure of IRA if ray RI bisects SRA. So what does that mean? Let's go break that up. Find X and the measure of IRA. So this is what they want. I to R to A. what does this angle equal right here? So this 4x plus 2, 7, right? So this right here that's our 4x plus 27 degrees, okay? We know that the ray RI, here in green, it bisects SRA, right? So this one here, from S to R to A, it bisects that, which means it cuts it in half. Well, if it cuts it in half, guys, then this angle here and this angle here are equal, right? So at this point, we know, oh, in that case, then SRI, this angle here, right, that's equal to 7x. And if these two are equal, then it would hold true that 7x is equal to 4x plus 27. So let's go ahead and solve for x now. So minus 4x, both sides, minus 4x. That goes away. I'm left with 3x. I know some of y'all like this. Equals 27 divided by 3 on both sides. Okay, and I'm left with x equals 9. Okay, so x equals 9 there. Now, we found x. Perfect. Good. Check. But we also need MRA. Excuse me, the measure of IRA, which is this angle here. So let's go ahead and substitute our x value into that expression. 4 times x, well in this case it's 9, we know that, plus 27. Okay, and we here would get 63 degrees is equal to the measure of angle IRA. Okay, go ahead and let's go ahead and do a your turn now. See. Let's go ahead and push pause and try this one on your own. All right, so we're asked to find x in this particular situation and the measure of AEV. Okay, so that would be, AEV would be here, that's what we want to know. And we're told, I'm just going to write it out here, that AEV is equal to 6x minus 10. We're also told that DEV, the whole thing, right, from the blue part, DEV is equal to 52 degrees. So the whole thing from here to here is equal to 52 degrees. So we know DEV equals 52 degrees. That's angle DEV. So if that's the case, let's think about this. We know that this angle bisector cut this large blue angle into 2 congruent parts. Okay? And I know that the whole thing is 52, which means half of 52 would be 26 degrees. So then it would hold true that 6x minus 10 is equal to 26 degrees. At this point, it's just a matter of the algebra. Alrighty. We also know that the measure of AEV is equal to 6x minus 10. So now that I know my x value, I'll do 6 times, well, in this case 6, is 36, minus 10 is equal to 26 degrees. Okay, and again, we knew that because there it is right there. So we needed x, and we also want to know what AEV was. In this case, we knew it was 26 degrees. All right, let's move on. I'll take a my turn here. QE is the perpendicular bisector. Now this new one, not just an angle bisector, but a perpendicular bisector of MU, right? Which means that it forms that 90 degree. Let's do that in red so it kind of pops out a little bit, right? Perpendicular bisector of MU. Find the value of M and the length of ME. Okay, so you find the value of M and the length of ME. Okay, so let's take what we know. We know that basically there's a 90 degree angle in here. We also know that this angle here is equal to 4m plus 22. We're told that. We're given that. So then 4m plus 22 degrees, put 20, is equal to 90 degrees. So now it's just algebra at this point. Minus 22, minus 22. So m would equal 17. So we're asked to find the value of m and the length of ME, right? So m, right, is 17, and the length of ME, well, ME is right here. Okay, ME is right here. If that's the case, well, we know what m is. So we're just going to plug in substitute the values. So 6 times 17 minus 3. And this equals 102. Okay, so that is the distance or the length, right? That is not an angle. That is a distance, okay, from ME. So that's the two pieces we're asked for. Let's go on. Okay, so you're going to work on these independent practices. Number 1, 2, 3, 4, 5, 6, and then an exit ticket. Keep it a little bit short today. So go ahead and look at the first part here. Independent practice. It says find each figure shows a triangle with one of its angle bisectors. Find the measure of angle 1 if SUT equals 22. So let's look at this. SUT, right? It's really hard for me to kind of get in there, but SUT is that part right there. Let's just point here. So SUT, we know that's the angle right there. And that's SUT. If angle 1, well, angle 1 is half of that, right? Because angle 1 plus angle 2, so let's make our statement here. Angle 1 plus angle 2 equals, well, SUT is this whole thing, right? So if SUT is from here to here to here is the whole angle, well, measure 1, angle 1, and angle 2 added together would give me 22 degrees. We're told that. So if that's the case, well, what's half of 22? That would equal the measure of angle 1. So the measure of angle 1 is equal to 11 degrees. Okay, you're going to work the rest of them like that. Let's look at this one over here. DOG is an equilateral triangle. Equilateral. Triangle DHG is congruent to triangle OHG. Actually, I apologize. We're not going to do this one here. I'm actually going to go ahead and delete it. I'm actually going to delete the last two independent practices, so you can go right into the exit ticket after you finish the first 4 independent practices. And that is all. Text me or message me if you have questions. Have a great day, guys. Thanks.